How do we multiply and divide complex numbers in polar form? Well, we talked about a proof yesterday, and it gave us the answer on the left for multiplication. We're going to multiply the magnitudes and add the angles. Uh, Division is the inverse operation of multiplication, so we will do the opposite. We'll divide magnitudes and subtract the angles. So let's do some examples. So this is multiplication. So we will multiply the magnitudes, 3 squared is 31, and add the angles. So 11 pi over 6 plus pi over 6, that's 12 pi over 6. 12 pi over 6 plus I sine 12 pi over 6. Now, you should recognize 12 pi over 6 because 12 pi over 6 is a special angle. It's 2 pi. We should simplify it further. So this is cosine of 2 pi plus I sine of 2 pi. And we know that cosine of 2 pi is 1. We know that sine of 2 pi is 0. So the whole thing turns out to be 3 squared is 31 times 1, or 3 squared is 31. And that's much cleaner than doing the distributive property and then multiplying out the polynomials. Let's divide these. Well, division, we're going to divide the coefficients and we'll subtract the angles. So cosine 7 pi over 4 minus 2 pi over 3. And then sine will have the same angle. I'm going to save time and not rewrite this over here because I know that I'm going to be simplifying it in both cases. So we have 3/4 times cosine. We'll get, what is this? 7 pi over 4 minus 2 pi over 3. Those have a common denominator of 12. So this would be 21 pi over 12 minus 8 pi over 12. 21 minus 8 is 13 pi over 12 plus I sine 13 pi over 12. And this will be fine. If you want to simplify 13 pi over 12 further, you can using half angle formulas, but this will be fine for our purposes. How do we do this? Well, this is like the previous ones, except this is in degrees, not radians. So we'll still multiply these. 5 squared is 14. And now we will add the angles. 120 plus 90 is 210. And depending on what form you're looking for your answer in, you might continue further. For now, I'll just say that this is acceptable. We're going to divide the coefficients and subtract. Now, it's always going to be the numerator minus the denominator. So 150 minus 315 is negative 165 degrees. And this will be fine. Be aware that you might see the answer written with a coterminal angle. So a coterminal angle to 165, if you add 360 to this, then you'll get that it's coterminal with 195. So that might be the answer that you see in a multiple choice. Now, what's different here is we have an exponent. Well, exponents are repeated multiplication, so we'll be multiplying square root of 6 times square root of 6 times square root of 6 times square root of 6, so we'll have square root of 6 to the 4th. And then for the angles, we'll be doing 4 times each angle. So cosine of 4 pi over 6 plus I sine 4 pi over 6. So square root of 6 to the fourth. Oh, well, that's the same thing as 6 squared. And this is 2 pi over 3. And so our final answer can be 36 times cosine of 2 pi over 3 plus I sine of 2 pi over 3. Now, it's worth pointing out, if the question asks for the final answer to be in rectangular form, then you need to do this out, and that would be using what we know of cosine of 2 pi over 3. Cosine of 2 pi over 3 is negative 1/2. And this is square root of 3 over 2. So it would have as negative 18 distributed in, plus I times 18 squared is 3, which we usually don't write that way. We usually write negative 18 plus 18i squared is 3. Now this one, what's tricky about this one is that it's not written in terms of magnitude and rectangular coordinate or polar coordinates. It will be easier if we turn this into polar coordinates than if we do this binomial times itself 8 times. You could do this with this binomial times itself 8 times, but it's going to be easier if we find the magnitude. So let's find the magnitude. And the angle. So this will be square root of square root of 2 squared plus square root of 2 squared, 2 plus 2. So the magnitude is 2. And then the angle, this is going to be square root of 2, square root of 2. So if we take arctangent of square root of 2 over square root of 2, and we're in the first quadrant because both of them are positive, arctangent of 1, you should know, is 45 degrees. So now we can rewrite this whole thing as the 8th power of 2 times cosine 45 degrees plus I sine 45 degrees. Now you don't have to do this. You could do it out the other way, but I honestly believe that this will be faster, because now we're doing 2 to the 8th, and then we'll do 8 times 45 degrees, and I sine 8 times 45 degrees. 2 to the 8th is 4 to the 4th, which is 16 squared, which is 256. And cosine, 8 times 45, that's 360 degrees. Therefore, what we have is this is 1, this is negative 1, so we have times 1, 256 times 1, 256 is our total value. That is far faster than doing square root of 2 times I squared to 2, or square root of 2 plus I squared to 2 times itself, times itself, times itself, times itself. So this is really helpful for multiplying complex numbers, to convert them into this trigonometric form or polar form, and then raise the magnitude to that power and multiply the angle by the exponent. Thanks.